So, describing the distribution box and whisker plot, where we have a guided practice question, cell phone. Amani's parents have given her a prepaid cell phone. The number of minutes she used each month for the last 2 years are shown in the table. So, A, use a graphing calculator to create a box and whisker plot, then describe the shape of the distribution. And then B, describe the center and spread of the data using either the mean and standard deviation or the 5-number summary. Justify your choice. So the first we're going to do is use Desmos to create our box and whisker plot. So just going to go to Desmos. Okay, so in Desmos, the first thing we're going to do is create our data set. So we're going to put D equals the square brackets. And then we need to type in our data. So we've got 582, 608, 670, 620, 667, 598, 671, 613. And I'll just put the rest of that in. Okay, so we've got our data, 24 items. So now we're going to look at drawing our box plot. So again, we're going to go over to the function. We're going to find box plot. And then our data set is D. We're going to exclude the outliers. And we're going to minimize this. Okay, to find, so we're on all the way over here. So let's maximize here. So maximizing our data. So our minimum value, let's check our minimum value. So the minimum of D is 511. So let's see if we can make this a bit smaller. So we'll be able to see. So we've got 511 here. This is our minimum value. And then our maximum value. Okay, so I've just changed the settings. So I've looked for our minimum values 511. So we could change this, say 500, because we know that is just less. And then our maximum value of our data, so 695. So going back to settings, so we can change the maximum value to 700. So this will all fit on our page. Okay, so we've got the minimum, we have the maximum. So now we need our quartile one. So quartile, so D, 1. So this is 616.5. So this is this value here. And then we want our median, which is quartile 2. So our median, which is 50% of our value. So this is going to be of D. So this is at 65.5. Quartile 3. So quartile D, 3. This is at 75% of our values. So this is at 670.5. And then we want to find out where our mean. So we can put in our mean. So mean of D. So this is 639. So our mean is actually here. This is, so the other thing we want to look at, so our function. So on our stats, we have something here called the standard deviation. So standard deviation of D. So this can tell us the distance from the mean. So at one standard deviation, so the difference from the mean. So we've got 46.19. So what we're going to do is use a calculator. I'm going to put the data into a calculator. So we're going to put the values into our table. Now, if you have an older value, you'll be going to the mode and to your option, which may be option 3 for table. And if you have this here, if we're going to go for 6, which is going to give us our one variable, which is our x. So we're going to put in our values for our data set. So we've got 582, 608, 670, 620, 667, 598, and I'll just continue with that. Okay, so we have all our data in our table, 24 values, so we can see all our data is here. So what we need to do now is just press cancel, and we're going to go to option. Now on this calculator we can press 2 for one variable calculation. If you have the older type, you'll be pressing shift and stat, which will be an option by here somewhere, and you'll be able then to choose your values. So the mean we have here 639,375. 639,375. So we have, so looking down at our values, so we've got a standard deviation. So this is our SX on our calculator, 46.195. So this is what we have here. And the value of N, 24. Minimum value is 511, which is what we have here. The median value, 655.5, which is what we have here. Our quartile 1, 616.5. And then quartile 3 is 670.5, and then finally we have 695, which is our maximum value. So all our values on our standard deviation on our calculator. So what we need to do now is just compare our values. So if we were to use the mean and the standard deviation, we can say that the mean is 639, 639.7, and then the distance, the data, is going to be 46.2. And, or if we look at our calculator here, we're looking for SX, 46.2. So our conclusion. So the length of the whisker, you can see on the left, is a lot longer than the whisker to the right. The median is closer to the right whisker, or to the quartile 3 up to here. So this would indicate a negatively skewed distribution. So if we were to look at the minutes for the data range from 511 to 695, the median is between 655, so half the minutes used lie between 616.5 and 670. So here, 6.5 and 670. So this is 50% of the data.